So in last lecture we have seen operators in C language. Operator are three types. First one is the unary operator, next is the binary, and third one is the ternary operator. Unary, that means it's need one operand to perform that task. Binary, that means that needs two operand to perform that task, and ternary, that means three operand to perform that task. Suppose we will move to the arithmetic operator. So arithmetic operator is the binary operator. Why binary operator? Because arithmetic operator, suppose I will do addition, so I need two operand to perform task, I plus j. So I need two operand to perform task like that way. So it's called arithmetic operator is binary operator. Like what is unary operator? Suppose I will do not, complement, increment, decrement, like that way. This type of operator is called as a unary operator. And ternary operator, that means it needs three operand to perform task. So I have make list which type of operators. So arithmetic operator, that are the addition, subtraction, multiplication, division and modules. Then relational operator are mostly useful for the comparison. So it's greater than equal to, less than equal to, or equal to, not equal to. So in C language, equal to sign is double equal to. Single equal to is called as assigning operator, assignment operator. Logical operator, and, or, and, not. Bitwise operator, that means it is on doing operation with the bits only. So we will see bitwise operator and logical operator difference and things. Then shift operator is also part of bitwise operator. It is also doing things with the bits only. So there is two type of left shift and right shift. Next is the increment and decrement. Then assignment operator, comma operator is for the separation. Reference operator, this is for the address. So we have to pass address and we have to read address at the time of pointer, and in the scanf also we have used this address operator. Next is the dereference operator, is we will see in the pointer. Index operator we will cover in the array. Grouping operator, so it's have a highest priority. Then dot operator we will see in structure, arrow also. Compound assignment operator we have already seen. So we have to do increment, or sorry, addition or subtraction or multiplication, division with itself only. So at that time we will use this compound assignment operator technique. Size of operator will give you size of your data type or the variable. Conditional operator is ternary operator, we will see that part. So this is unary operator, binary operator, and the after that I have started arithmetic operator. So arithmetic operator, addition, subtraction, multiplication, you know what that will do. In here, division and modules have little bit. Suppose I will do 10 divided by 3. So 3 3s are 9, and my remainder is 1 and quotient is 3. Suppose I will do 10 divided by 3. At that time my output will be 3. So it will give only 3 output, not give real number output. In the case of float and double, it will give the real number 3.33, but in the case of normal integer it will give the output 3. So what is my remainder? If I want my remainder, at that time I will do modules. So 10 modules 3, my output will be 1. And in the case of float, modules will not work. So modules will work in the case of normal integer or normal character. And then we have seen the assignment operator. Assignment operator is useful for the storing data of whatever the right side to the left side. So suppose I will store data like this, where I is equal to j is equal to 10. So my execution is started from right to left. So 10 will store into j and j data will store into the I. So I and j both value are 10. Suppose I will do this type, I is equal to 10 is equal to j. At that time my compiler will generate error. Why? Because I am storing j is equal to 10. Constant is not allowed left side. So we can only store into the variable. We cannot able to store j data into the 10. So this is not possible. Because of that reason it will generate error. Next I will move to the code. So we have seen one program that is swapping of two number. Suppose I have two number, n1 is equal to 10 and n2 is equal to 20. I have to swap that both numbers. So how I will do? First technique we have seen is using temporary variable. So I will store n1 data into temporary variable. and then after we will do swapping of that. So like this method, we will swap that number. Another method we have seen is the addition and subtraction method. So first we will do addition of two numbers. So here 10 plus 20 is equal to 30. My n1 is 30 here in this line. N1 minus n2, my n1 is 30 and n2 is 20. So n1 minus n2 is 30 minus 20 is 10. So my n1 become 10 here. Sorry, n2 become 10 here. And n1 is equal to n1 minus n2. So n1 is 30 and n2 is 10. 30 minus 10 is 20 here store. So n1 become 20. So like this way. So multiplication and division also. One more method I have give you for the homework. So you have to find solution for single line. How to swap single line. So n1 is equal to n1 plus n2 minus n1 is equal to n2. This is the solution for single line. So how it will do? So think this is my expression. So how is the priority? Priority is for the, as per the board mass rule, first priority is go to the
Bracket.
parenthesis bracket, and then addition, subtraction, division, and multiple board mass rule like that way. But here how I will do. So I will do, this is my expression like that way. So what is my n1? 10 plus 20 minus expression. So 10 plus 20 is how much? 30 minus this is my expression. So what is expression? N2 data whatever it will store into the n1. Sorry, not n2 is equal to n1.
In
Otherwise it will get confused here. Here also I am storing to n1. So here I have to store here n2. So in this expression my n2 will update it. So n1 data store into the n2. That is 10. So here my output 30 minus 10 is 20. Now my n1 is become here 20 and n2 here become. So using this single line expression, we can able to swap two numbers. So I'll write down here. N1 is equal to N1 plus N2 minus N2 is equal to N1. I will run this code. Yeah, you give me the number.
maybe something like 26 and
And
34. Yogin, I have one more question here. While I was going through the last lecture, I have a doubt that when we do the scanf, we like store the value in. First, we write the and then we write the variable. For example, and n1. But when we do the printf, why don't we do it in a similar way?
yes, so I will show you. Here you can see in scanf I have used address of I and address of j. But in the
Hmm.
printf we are not doing this.
Yes, but
Yeah, because of that reason, scanf is working at the runtime.
okay.
So first is the scanf is running at the one time. What is the purpose of scanf? We have to take data from the user.
User. Hmm.
I have to take data from the user. Where I need to store. I have to give direction to compiler. I have to store there. So
Hmm.
address, that means I have to give address to that variable.
Hmm. Hmm.
Because of that reason we are giving address to, you have to store there.
Okay.
So you will understood clearly address concept in the pointer. So we have to store where because this data is running at the runtime, not compile time.
And printf works like on static values. Is it so?
Yes, printf needs to do only print the variable. So it's like a already defined variable is there, and there is printf know where is the address and what is that. Printf don't want to store data anywhere or on. It have to take data from their address automatically by default. I will pass a variable name, so it will take that data and it will print whatever format specifier I will give in that format.
Okay.
So here it address, that means it have to give location for that. I
Mm-hmm.
have store I, so I is 1000 location, J is 1004 location. So this 1000 location it will give by the address sign.
Okay.
So at the runtime, whenever we enter data, so it will store in this particular location.
Okay. Uh, but even if like when we do the scanf and we are getting some ij values, the k value is continuously changing, na? So like how does it become a static value? Like it is not going to change.
Static that doesn't mean it's constant.
Okay.
So it's a variable. We have to change so we can change. So there is one more type qualifier we will see in this course, that is constant. If I will make my variable constant, then after I will not able to change.
Okay.
So always whenever you get confused and like that way, so you have to find purpose. So why we are doing this, why we are changing this variable, why we are using scanf. So scanf is using for the taking data from user. So at the runtime or compile time, which time it is doing, like that way. So you, like that way you will debug.
Yes.
So one more thing we have seen, that is this assignment operator. If I will do like this way assignment, so it will generate error. Okay, so today we will start from next operator is the relational operator. So it's greater than equal to, less than equal to, is equal to, not equal to. So this all are the operator is relational operator. All the relational operator are the binary operator. It needs two operand to perform task. So all the relational operator are the binary operator, and it needs two operand to perform task. That means we need one in the left side and one thing we need the right side. All the relational operator are maybe 0 or 1. So that means true, that means 1, and 0 that means false. So relational operator will not modify the operands. So what is the meaning of this line? So first thing, why we are using the relational operator? Relational operator useful for the condition checking only. Suppose I will do I greater than j. So what is my output? It is either true or false format. So I is greater than j or not. So it will give output in the form of true or false. Similar way, it's greater than equal to or less than equal to or not equal to. But this relational operator will not change my operands. That means it will not change my I value or it will not change my j value. So this we are generally using in the conditional only. So if and else and like that way we will see the conditional at the chapter next chapter control statement. What is my output here? K, I, J and K.
I still
120
And K.
0.
10 is greater than 20. So this condition become false,
false
and the data will store into the K is
0.
0.
0
Okay, so like this way, greater than or equal to, suppose I will do here greater than or equal to 10. Now what is the output of K?
0
Yes, again 0, because it's not
Mm,
equal to 10. Suppose
right
my here, suppose my J is also 10, suppose. 10 is greater than 10. So what is my output here?
0. If greater
Exactly.
than or equal to
Equal
10,
to,
then
then it will be
it
true.
will be true. Yes.
Here also 0. Suppose I will look k is equal to I less than j.
So it's true. Yes. So 1.
Yes. Is equal to I less than or equal to j.
It's again 1. Yeah. True.
K is equal to I is equal to j.
Oh, it's false. So 0.
K is equal to I is not equal to j.
Yeah, it's true. So 1.
Okay. So like this way we are using the relational operator inside the condition. So inside the condition we are writing I greater than j, I greater than or equal to any of this one we are using. So you will also use when we start the control statement and if else condition looping concept at that time. For the condition checking purpose only relational operator is.
Hello, Yogin.
Yes.
I think on the 11th line, it should be k is equals to I less than equals to j.
Yes. Then next operator is the logical operator. So logical operator we have and, or, not. And or both are the binary and not is the unary operator. So here in the result we also get similar like relational operator. It may be true or false, maybe 1 or 0. Logical operator will not modify operands. So logical operator is similar like relational operator we are using in the conditional case only. So it is also give us the output in the form of 0 or true or false only. It will also not modify the operands. So everyone knows about the truth table of logical. A, B. 0 0 0 1 1 0 1. What is the A ending with B? A ORing with B.
For
Ending
the
that. Yes, Radhika.
for
Multiplication.
the first case only, A ending with B, only one will have the output one, rest will have the value 0.
Yes, for shortcut, ending is the multiplication and ORing is the addition. So if someone is new to these things, so you have to think like ending is the multiplication. Suppose I will do 0 multiplication 0, so output is 0, 0 multiplication with 1, 0, 1, 0, 0, and then here 1. ORing that means addition, 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is considered as a 1 here. Here not 0 and like that we carry 1 and like here we have to consider 1. This is for shortcut. Okay, then not truth table. So here I have only one operands, either 0 or 1. If it is 0 then not A is 1, and if it is 1 then not A is 0. So next line is operands non-zero consider as 1. So in the logical operations, operands non-zero consider as 1. That means suppose I will do 10 logical operation ending with 20. So what is my output here? So all the non-zero will consider as
1.
1. So 1 ending with 1 is my output 1. So here my condition will true. Suppose I will do 10 ending with 0. Then only my output will become false.
0.
Okay. So this is why we are using logical operator for the conditional checking purpose. So at the time of condition checking, we have, so what is the real life use case of logical operator? Anyone knows?
To eliminate maybe the condition of maybe a fault condition where you where you don't want an output as zero, but to check the condition if we are getting zero or not, something like that. For example, checking for null pointer or something maybe like that.
No. So use case of the real life use case for this logical operator is in the checking part of the condition only. So we will see. If you will not understood now, so don't worry, we will see later. But what is the exactly root use case is like that way. Suppose my if condition, I am checking the here condition. Okay, I have two things to do here. If my condition 1 will fulfill, condition 1 and condition 2 inside my if only, I have two condition here, 1 and 2. If my this condition will fulfill or this condition, either one condition will true, I have to pass this as a true. Suppose this is my I less than j and this is my I less than or equal to j, or something like other conditions, this is my k and l. So I have two condition here. Suppose both will either one true, at that time I have to pass this condition and I have to do some expression in the if. So at that time I will use logical or in between these two condition. So I will write like this when my if I less than j, logical operation of ORing with k less than or equal to l. So this time I will use logical or. Either this true or either this true. It will work. Any of both are true, at that time only I have to do condition. Suppose this true and this is false, at that time I don't want to do, at that time I will use logical and operator. So this true and this false, at that time this will not work. If both will true, at that time only this will work. Understood this? Suppose in the automotive you are turning on two lights at the time. Suppose one is not on and another one is on. At that time you have to don't on to and you have to do a failure message in the case of else, like that way. So in the real time, like that way, we are using this logical operator. You will understood what is this if condition and all things later. But this is the real life use case of logical operator. Then I will move to here and I will k is equal to I ending with j. So what will be my output here? What is my I?
100, 0,
J.
0.
Yes. Why? Because 100 is ending with 0. 100 will consider as a 1. All the non-zero value will consider as a 1 only in the case of logical. So 1 ending with logical ending with 0. That means 0. Okay. K is equal to 0. So write down this program. Next is the not operator. So I'll make one p9.c. Suppose I will take integer I is equal to 100, comma j is equal to 0, k is equal to. Suppose I will do here not I. So here no need to j and k. And here again I. So what is my output here?
0.
Okay, I will run this code. I is 100, not 0, because here I am not storing to anything else. Yeah, suppose I will do like that where j is equal to in comma j, and here I will print j. My I value will not change. Logical operator will not change my operands. It will perform task and then exit. So here j is my 0. Why 0? All the non-zero will consider as a 1. So here not 1, that my output should be 0. Not 1, that means 0. Not 0, that means 1. Suppose I will store here I is equal to 0, then my output should be here 1. So like that way we are using not operator. So next, type conversion in C language. Type conversion. So there is two type of type conversion. One is the implicit and another one is the explicit. So implicit, this is the automatic type conversion, and explicit, that means we are doing by ourselves only. So I will write down the flow of the data type. So lowest part is the character, then short integer, then long integer, then long integer, and float. Float is the real number and long integer is the normal or decimal value. Then double, then long double. This is highest rank and this is lowest rank.
Yes.
Okay, and then I will move to code and I will run down one code. Suppose I will do one unsigned long integer. I is equal to 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that way, and number of zeros. Unsigned long integer k, and j is equal to only 3. So I will print this printf I is equal to percentage long unsigned. Long unsigned, for that we have either we can do percentage d for the decimal. Long unsigned, we have one format specifier is the lu, comma j is equal to, this is my long, so I will use like that way, llu long unsigned, k is equal to percentage long unsigned slash n, comma I, comma j, comma k. So I will run this. What will be my output? I is this value, J is 3, and K is the random number. So here K is random number. So this is my length of the long unsigned. Because of that region it will print. This is the random number. Okay. Now I will do K is equal to,
Yogin, I have a question here. When we don't define any value for k, so doesn't it take the default value as 0?
no. In the case of local, so inside functions we are writing the variable any, it's called a local variable, and local variable will not assign any by default initialize at the time of initialization any value. So it will take any uninitialized data, that is the random data or the garbage data we can say.
Okay. So if we want, then ideally we should define it some value so that it does not take a random
So
garbage value. Yes.
yes, we can, generally we are assigned to 0 or FF like that way.
Okay.
Suppose I will do K is equal to I into J. So I is my long integer. Long integer is normal integer only. So both are same. K is my long integer. So I is how many bytes data store? 4 bytes. And J is 8 bytes. Suppose and K is also 8 bytes. I will do multiplication 4 byte data to the 8 bytes. So my data will store in the form of 4 bytes or 8 bytes.
8 bytes.
Exactly, in the higher bytes. So compiler automatically convert lower byte data to higher byte. So this is my automatic type conversion will happen here. And it will convert this 8 byte data to the, 4 byte data to 8 bytes internally. So this is like normal. I will print here and it will print whatever the multiplication is this number to this 3. It will store into the K and K will print. So this is my K. Okay. Suppose I have integer L, character ch. Ch is equal to A and L is equal to 10 suppose. So I will do L here. L is equal to ch. Then my data will store into the form of integer. Character will data will store in the form of integer. And here I will print L is equal to percentage %d comma L. So I will run this code. My L value is 97. Suppose I will do here ch is equal to L. Ch is equal to percentage %d comma ch is equal to percentage %c. Ch comma ch. So what will be my output here? Here integer data converted into the form of character. So here I will take 65 suppose. Why 97? Here ch is also 97 and a it will print because here we have modified the value of L. So that modifiable value will go to here and it will store into the character. So understood this. So do practice like this way implicit typecasting. Tomorrow we will see explicit typecasting, and then we will start bitwise operator and all.